find the equivalent resistance, the current out of the battery, the current through each resistor, and the voltage drop across each resistor. And obviously, this is for the circuit shown here. So we'll start by finding the equivalent resistance. So I've got this here, R1, and it's connected in series with this combination, and this combination is connected in parallel. Okay, so start there. I'm going to find 1 over R2, 3. I'm going to find the equivalent resistance for 2 and 3. They're connected in parallel. So I've got to do this. So this is 1 over 3 plus 1 over 2. Okay. Common denominator is 6. So this is 2, 6 plus 3, 6. Okay, so 1 over R2, 3 is 5, 6. So that tells me R2, 3 is 6/5, which is 1.2 ohms. Okay, so now Req is going to be R1 plus R2, 3, because again, this combination is connected in series with this resistor. I know that because there are no junctions between this resistor and this combination. The combination, there's no junctions between them. So when we do this, Req, this is 4 plus 1.2. So of course, Req is just 5.2 ohms. Okay, so now I found Req. Now, to get the current out of the battery, we will set up, I'm going to redraw my circuit, putting in the equivalent resistance here. Here's V0, okay. So this is my current, I0. Set up the loop rule. It's going to be V0 minus VEQ equals 0. Okay. V0 is going to be 26, and this has to equal I0 times Req. So 26 equals I0 times 5.2. And 26 divided by 5.2 is 5. So the current out of the battery is 5 amps. Okay, now I need to find the current through each resistor and the voltage drop across each resistor. Okay, to do this, I want to eventually do my loop rule, but first I start by doing the junction rule. Okay, so this is I0. Notice that I0 is going to go through R1. Okay. And then here at this junction it's going to split. This will be I2, and this is I3. And so my junction rule, when all is said and done, I'm going to have I0 equals I2 plus I3. Okay, so of course I don't know I2 and I3, but now I can set up my loop rule. I'm going to go clockwise. I'm going to do this loop first, going through R1 and R2. Okay. So when I do that, that's going to be V0 minus V1 minus V2 equals 0. Okay. So V0 is going to be minus I0 times R1 minus I2 times R2. That's equal 0. Okay, so now at this point I know V0, that's 26. I0 is 5. R1 is 4. Don't know I2, but I do know R2, that's 3. Okay. Just go ahead and make that an equals. This is 26 minus 20, so this is going to be 6 equals 3I2, and so I2 equals 2 amps. And since I2 equals 2 amps, V2 is just going to be I2 R2. And so that's just 2 times 3. And so V2 equals 6 volts. And as I do that, I realize I can also quickly get V1, which I haven't done yet. So let me do that. Oops. V1 is just I naught R1, which is just 5 times 4, and so V1 is just 20 volts. Okay, so last thing to do is to find I3. So I need to do another loop rule. Actually, I don't need to do another loop rule. I take that back. I could, certainly I could, but I can just use the junction rule. So to use the junction rule, I naught equals I2 plus I3. Oops. I naught is, well, let me just write this all down. So I've already written down my junction rule before. This is right here. Okay. I naught is 5 amps. I2 is 2 amps plus I3. So obviously I3 is 3 amps. And then finally, to find V3, that's just I3 times R3, which is just 3 times 2. And so V3 is going to be just 6 volts. Which shouldn't come as a surprise that V3 is 6 volts because these two resistors are connected in parallel. And for resistors that are connected in parallel, they have to have the same voltage drop. So since V2 was 6 volts, that told us immediately that V3 had to be 6 volts as well.